Hello everyone, this is the 2023 Level 2 Math is Level 2 Probability paper. Let's get right into it. So, Alex likes playing the claw game at the arcade. She finds out that machines are programmed and are not based on the skill of the user. A particular claw game that Alex plays has these settings. In 15% of the games, the claw picks up a toy but drops it again. Out of the other attempts, about 1 in 10 games will be selected to be won by the machine generating a random number. So this means probability the first game is one. The first game is one is that seems like a typo. This means the probability that the first game is 1 out of 10. If a game is not 1, then the probability of the subsequent games will change as the remaining random numbers decrease, i.e. the probability of the second game will being 1 is 1/9, and so on. One day, Alex watches someone else win a toy, and then she plays the claw game with this strategy. If she wins a toy, she stops. If the claw drops the toy, she always tries again. If she keeps playing until she has 2 losses without it dropping, or a maximum of 4 games in total. Complete the tree diagram below and use it to answer the questions on the next page. So basically, this is 1 over 10, 0.15. So here is 1, take away 1 over 10, take away 0.15. That is just equal to 0.75. So here is 0.75. Then this probability here is likewise 1, take away 1 over 9, take away 0.15. So that is that's 0.739, and I'm guessing what they mean is the remaining random number decrease. I'm guessing it's subsequent. The odds just subsequently decrease, so this will be 1/8. The chance of dropping will always be it's always 0.15. So here's 0.15. 0.15. I'm guessing this becomes 1 over 7 here. This is 1 over 8, 1 over 7, 0.15, 0.15, 0.739, 1 over 8, 1.5, 1 over 7, 0.15. Here is 0.725, there is 0.725, and here is 0.707, 0.707. Okay, so what is the probability that the claw drops on the first game and Alex wins the second game she plays? So we're going so first game it drops, so we're going through this. I'll pick a different club pen. So basically she drops it, then she wins it. So we follow this path, which is just probability of drop, then win is equal to 0.15 times 1 over 9. This is equal to 0.0167. Let me just check. Yeah. Okay. I have a note of paper since this paper was like extremely difficult. Like, I mean, not extremely, but I feel it was quite difficult compared to normal years. What is the probability that Alex wins the third game she plays? So now we're following the probability of third game. So here, then here, or let's make that a bit smaller. Here, and here, or here, here, and here. That's the only 3 ways that that Alex wins on the 3rd game, in the 3rd game she plays. So probability win on 3rd is equal to 0.15 times 0.15 times 1/8 plus 0.15 times 0.739 times 8 plus 0.75 times 0.15 times 1/8. 0.75 times 0.15 times 8. This, adding this together is 0.15 plus 0.15 times 0.739, 0.75 times 0.15 is equal to 0.031. It approximates to 0.031. What is the probability that Alex wins the claw game within a maximum of 4 attempts? If it is within, okay, I'll just delete all this unnecessary, everything that's unnecessary. So if it's within, then that just means discounts, this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, adding all of this up, which is a bit of a pain. Within, so actually we already calculated the probability. So probability win on 1st is equal to 0.1. Probability of win on 2nd is equal to 1/9 times 0.15 plus, yep, we can follow this path, plus 0.75 0.05 times 1/9. We know that probability win on 3rd. This is equal to 0.031. Probability win on 4th. This is very tedious. So this, oh wait, I forgot to write. 725. So probability win on 4th is equal to 0.15 times 0.15 times 0.15 times 1/7 plus, yeah, that was this curve. Now we go here, 0.15 times 0.15 times 0.725 times 1/7 plus 0.739. 0.15 times 0.739 times 0.15 times 1 over 7 plus, then here, here, 0.75 times 0.15 times 0.15 to 1 over 7. This is equal to 25 plus squared. This is equal to just double check. 0.15 cubed times 0.15 squared times this plus 0.15 squared times 0 times this plus 0.15 squared times this. Yep. 0.007599. So this plot, so probability of win first, probability of win second, plus probability of win third, probability of win fourth is equal to 0. Oh, I never calculated this actually. 1 over 9, 0.15 plus 0.75 times over 9. Oh, that's just equal to 0.1. Yeah, wait, is it? Wait. Wait, this figure is very. Oh no, never mind. Yeah, 0.1 plus 0.1 plus 0.031 plus 0.007599. This is equal to. Oh, scheiße. Never mind. 599 plus 0.031 plus 0.1 plus 0.1. Oh wait, I got a different answer to what I originally had. Okay, I got a different answer to what I originally had, but wait, let me just I'll write this down and I'll check for now. Yep, so I just recalculated a lot and checked my answers thoroughly, and it seems like it's like somewhere between 0.236 to somewhere between 0.236 to 0.238 from my calculations. So I'm just gonna say probability on win by third. Oh no, not third, fourth. Fourth is equal to 0.238 or so. Yeah, this is what. Yeah, I've recorded this before the assessment schedules have even come out, so I am not confident with some of my answers. So yeah, let's calculate. Yeah, it's my other one. Okay, up here. So when Alex goes to the arcade, 70% of the time she goes with her friends. If she goes with her friends, she plays the claw just once and wins on 10% of these visits. If she is by herself, she plays multiple games and wins on about a quarter of these. So let's just draw the probability here. So this if for friends and A for alone, then here is win, here is loss, here is a win, here is a loss. We're given that friends, so 70% of this times is 0.7, here will be 0.3. Wins, well, 10% is 0.1, 0.9. A quarter was a 0. And she wins by herself 0.25, so hit 0.75. Yeah. Overall, what is the probability of Alex winning? Probability of win is equal to here, here. If we follow those two trees, we'll get it. So 0.7 times 0.1 plus 0.3 times 0.25. This is equal to 0.145. Alex after playing at the arcade. Alex often goes to cafe for a treat. If Alex lost the claw game but is with her friends, she is 3 times more likely to buy a treat from the cafe than if she was by herself. If Alex wins the claw game, she is twice as likely to buy a treat from the cafe than if she loses the claw game. She loses the claw game whether she is with her friends or not. Probability that Alex buys a treat at the cafe overall is 40%. Find the probability that on a random visit to the arcade with her friends, Alex wins the claw game and buys a treat from the cafe. Let's draw the tree here, down here, since I can't be bothered slipping back. So if friend alone, by the way, this question did stump me a lot. I couldn't try to figure it out for like an hour and I could not get it. And this T and T complement. This means not T. And T complement. T and T complement. T and T complement. So 0.1, 0.9, 0.25, 0.75. So if Alex loses the claw game but is with her friends, she is 3 times more likely to buy a treat from the cafe than if she was by herself. So how I interpreted this was, okay, so firstly I'll use the second info. If Alex wins the claw game, she is twice as likely to buy a treat from the cafe than if she loses the claw game, whether she is with her friends or not. So let's say the probability of winning is, well, winning here is A, and here, probability of getting a treat here is A. This will be 2A. Here is B and 2B, because winning, she is twice as likely to buy a treat from the cafe than if she loses the game. Okay, so that is the first info we use. If Alex lost the claw game but is with her friend, she is 3 times more likely to buy a treat from the cafe than if she was by herself. So that just means if she was by herself alone. So probability of treat and friends and loss is equal to 3 times probability of alone. This is a probability of alone. It is just probability of treat and alone, which is equal to 3 of probability of 3 of probability of treat and alone. So basically, these follow this line here for probability of with her friends losing and a treat. It lost the game, but it's with her friends. She's yeah, okay. So that's 0.7 times 0.9 times A is equal to 3 times probability of treat and alone. So this is here, 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 and let's choose blue. Here, here, here. So it will be 3 times 0.3 times 0.25 times 2b plus 3 of all of this. 0.3 times 0.5 times b. This is 63 over 100a is equal to 3 times 0.15b plus 0.225b. 63. Actually, let's divide by 21 over 100a is equal. I divide by 3. 1 over 3. So this and here cancels. 21 over 100 is actually it's a bit nice to express this as a fraction. So 3 over 40b plus 9. Oh no, this is 6 over 4. I'm pretty sure. I know this before. Yeah, 6 over 40b plus 9 over 40b. This is equal to 15 over 40b. Okay, so now probability that Alex buys a treat at the cafe overall is 40%. So if we follow all of these paths, and here, here, and here, so probability of treat is equal to 0.7 times 0.1 times 2a plus 0.7 times 0.9 times a plus 0.3 times 0.25 times 2b plus 0.3 times 0.05 times, right, yeah. This is equal to, from my notes, it's 14 over 100a plus 63 100a. Oh wait, oh no. Before that, this is equal to 0.4. So now we can do 14 over a plus 63 over 100a plus 6 over 40b plus 9 over 40b is equal to 0.4. This implies 77 over 100b 100a plus, and this part is equivalent to this part. So yeah, this. So 77a plus 2100a is equal to 0.4. Okay, now that this is irrelevant, I'll just rub it out. So this is 98 over 100, A equals 0.4. A is equal to 0.4082. Now, okay, find the probability that on a random visit, the arcade with their friends, Alex wins the claw game and buys a treat. I just go back. This is treat, and remember this was 2A. So, and yeah, we pick this path. So so probability of treat and friends and treat and friends and big fat W is equal to 0.7 times 1 times 2 times 0.4082. This is equal to 0.0571. This is the final answer I got after after contemplating for a very long time. So let's see. My next. Okay. The following results will report. Our survey of New Zealand media usage is completed regularly by NZ on air. The following results were reported from 2021 survey. 1,420 participants were asked if they had watched each of media types of the day before for at least 5 minutes. The data was split between New Zealand youth, New Zealanders aged 25 years or older. And the probability that a randomly selected chosen survey participant is a New Zealand youth who watched a streaming service that day before. So let's look at a New Zealand youth who watched a streaming service. Yes. So that is this box the day before. So, and this it is out of 104,220 students, so 191 before 1420, which is of Y for youth and stream is equal to 191 1420 0.13135. Tao looks at the table above and says that more adults watch online videos than youth. So this means adults in New Zealand are more likely to watch online videos than youth. Is he correct? Justify your answer using calculations to support your reasoning. Okay, so for online videos, let's look at the proportion of New Zealand youths who so the number of New Zealand adults who watch online videos is indeed more. But let's look at the proportion. So probability of youth that probability of youth watching okay, let's say OV equals online vid. Watching OV is equal to 228 over 251, which is approximately 0.908. Probability of 25 plus watch OV is equal to 610 over 1159, 0.522. Tau is Incorrect. Yeah, and then this clearly 0.908 is greater than 0.522 because he compares the number of people watching online vid. If we compare the proportion, then the more youth are likely to watch online video. The report wants to include an infographic showing the daily research of various types of media. Find the overall percentage of students using each of the 3 media types given according to. So it's just, we're not considering whether youth or adult, we're considering how many people watch it. So for online video, it's 838 out of 142. So proportion of probability of online video is equal to 838 over 1420 is 0.5901. Probability of stream is equal to 724 over 1, 724 over 20, which is equal to 0.5 0.5099. Probability of TV is equal to 795 over 1120. This is equal to 55.99. Oh no, is it not 55? 0.5599. This is approximately 59.01%, 50.99%, 55.99%. The report claims that New Zealand youth are about 70% more likely to watch streaming services, but over 40% likely to watch TV than New Zealanders aged 25 and over. Evaluate this claim using appropriate calculations. So we calculate the relative risk. So relative risk of New Zealand youth. Relative risk of streaming, and this is streaming, and this is comparing New Zealand youths to amount of New Zealand youth watching to New Zealanders aged 25 and over watching. Actually, I want more space. Easy way to memorize is the first thing that what you're comparing. What you're comparing are the first to the second, which so you're comparing the youth to the New Zealanders ages 25, and the variable that is mentioned first is what you put above. So probability of streaming is, so New Zealand youth is 191 over 191 out of 2 of 251. So probably relative risk of streaming is 191 over 251 or over 533 out of 1169. 3 over 1169. This is equal to 1.74. This implies youths are 1.7 more times likely to watch streaming service compared to New Zealand 25 plus. This is equivalent to youth 70 more likely to watch. Okay, let's do the same thing for relative risk of TV. TV services. So relative risk of TV is 90 out of 251 for youth, 90 out of 251 for youth, and 705 out of 1169. 705 over 1169 for New Zealanders 25 and above. This is equal to 0.5945. So youth 0.5945 times likely to watch TV compared to New Zealanders 25 plus. This implies youth is 0.59. So 1 take away 0.5945 is equal to like 40.5, 0.455, which is greater than 40%. Yeah. Okay. Yeah. I forgot. Convert this. This is 74% more likely. Youth is 40% less likely to watch TV compared to New Zealanders 25 plus compared to which means claim is true. The result of 4 similar surveys about media usage conducted in different years are shown below. How much higher is percentage of New Zealand youth who watch streaming services in 2022? Okay, thank God I'm recording. Last time I was not recording after I paused, so I'm genuinely frightened. How much higher is the percentage of New Zealand youth who watch streaming services in 2022 than it was 2016? So let's do the relative risk. 2022 versus 2016 is equal to 4. So 47. Proportion of youth who watched streaming. So who said yes. 473 over 706, all over 102 over 249. This is equal to 1.636. Therefore 63.6% percent more likely. Wait, oh no, not more likely. 0.6% higher. If 400 youths were surveyed in 2023, approximately how many would you expect to watch streaming services? Right. Let me pause for it. Let me think for a bit. Okay, so this is a bit unclear, so which assumptions to use. Yeah, this is a bit unclear how to use it, but I feel anything with like relatively good justification will be applicable. So you may have your own method, but this is how I did it. So approximately from 2020 to 2022, let's see, so proportion of youths who watch 2022 watch stream is equal to 181 over 262, which is 69.1%. Alright, proportion of 2021 watch stream is equal to 191 over 251, which is equal to 76.1%, and probability in 2022 watch streaming services is equal to 473 over 706, which is equal to 67.00%. So what I'm assuming is assume proportion in 2023 is average of the three. Yeah, this is like the only method I can think of. Wait, yeah, this is the only method I can think of. Tell me in the comments if I did this incorrectly. But I feel any other method is correct because they don't give us any more information. So 67 plus 76.1 plus 9.1 over 3 is equal to 70.7%. Then the amount of people, let's say, amount of people over 400 is equal to 0.707. Which gives proportion is equal to 282.9. So 283 or 82 people. A recent study reported that New Zealand youth aged 15 to 24 spend an average mean of 130 minutes per day watching streaming services. Assume the distribution of minutes watching streaming services per day follows a normal distribution with a standard deviation of 35 minutes per day. Find the probability that randomly selected New Zealand youth spend under 92 minutes a day watching streaming services. Actually, I'll get a formula sheet out. Yeah, I'll stop and yeah. No, I would recommend people to use a calculator, but yeah, I'll use a formula sheet since just doing it on calculator is lame, especially on this in a walkthrough like this. I think teaching it better. I think they'll teach it better. Okay, welcome back. So, this is a bit annoying. Oh my, this is a bit annoying. Okay, yeah, thank you. So what? Find the probability that a randomly selected New Zealand youth spent under 92 minutes. So, and then probability. So average is 113. Here is 92. So it's this region here. So that probability of x less than 92 is equal to probability is equal to 0.5. Since this half is just 0.5, take a probability of 92 less than x less than 113. We can convert 5, take away and then yeah, we can work out the z is equal to x take away mu over sigma z is equal to 92 take away 113 over 35, which is equal to negative 0.6. So take away 0.6. So the z value is 0.6. So let's look at the z value of 0.6, which is here. 0.6, which is 0. Yeah, actually, I use a different PDF, so I'll cut the recording. So welcome back. So 0.6 is here, which is here. Take away 0, so that is 0.2258. This is equal to 0.2742. I just check on my calculator. 92, 35, 113. Yep, that is close enough. Find the probability that a youth spends between 2 and 3 hours. So 2 hours equals 120. 3 hours, 120 min equals 180 min. So probability of 120 is an x less than 180. This is equal to so basically it's here's 113 and here is the region we want. We can get this by here is 180. Take away this I'll draw it a bit more clear. $180 take away $120, and we can get this region here from this. So probability of 113 less than x less than 180. Take away probability of 120 less than, no, take away 3 less than x less than 120. 120. Yeah, spider is right in front of me, but bothering me a bit. Not very nice. Probability of so the z values will be, I'll map these two out. So the z value will be, so 180 take away 113 over 35. .914, and the other z value is equal to 120 take away 113 over 35, which is equal to 1 over 5. The probability of the z 0 less than z is 1.94. Take away probability of 0 less than z less than 1 over 5. This, okay, so 0 to 1.914, 1.91, then there is a 4, here is 4, I think, yeah, that is 4, so, and here's 0.4719, and we had 2 to the 4th decimal point, so 0.4721 take away 0. So 1 over 5 is just 0.2, which is just this 793, which is equal to 0.3928. Yeah, I do recommend you to use a calculator for this. In the study, Zen youth were to watch online videos for 94 minutes daily on average, with a standard deviation of 30 minutes. Find the interquartile range, middle 50% for the number of minutes that New Zealand reportedly spent watching online videos. So the middle is 94. Here is a x value, and yeah, this is negative x. Here's 0.25, and the other here is 0.25. So yeah. So the z value for 0.25 is z is equal to, so we want to find 0.25 on this here, 0.2486, then we add a 13 since we do not want to go over, so that is 0.674, and basically z, yeah, so z is equal to x take away mu over sigma, sigma z, and yeah, there could be the negative z value plus minus the z value. Okay, so z is equal to x take away mu, so plus minus sigma z of, so mu plus minus sigma z is equal to x. So then we can plug in the numbers. 94 plus minus 30, I think. Yeah, standard deviation of 30 times 0.674, which is equal to 73.78 and 114.22. So probably 73.78 less than x less than 114.22 is the interquartile range. Out of a group of 15 New Zealand youth, how many respondents would you expect to have over 2 hours watching streaming services than online videos? So spending over 2 hours. So probability of 2 hours of 120 for stream. I think we calculated that before. Yeah, so basically for streaming services, we calculated that probability is equal to probability 0.5 take away probability of x less than 1 3 less than x less than 120.5 take away, which is this and this, so 0.0793, which is equal to 0. 0.0793, 0.421. Yeah. Then probability for online videos of x greater than 120. This is equal to online videos is, so middle is 94, here is 120 here, so 0.5 take away probability of 94, x less than 120, z is equal to 20 take away 1 take away 94 over 30. This is equal to 0.8667. Yeah, 94 over 30, so 0.8667. Let's look at 0.86. Or actually let's round up to 7, so that's 0.3. So probability of video, which implies probability of 0 less than z, then 0.8667 is equal to 0.306. So probability of OV is equal to 5 take away 0.306, which is equal to 0.194. So watching streaming service, would you out of a group of 50 New Zealand youth, how many respondents would you expect to have 2 hours have spent over 2 hours watching streaming services than online videos? So out of 50 people, so 50 times 0.421, so we want to see the difference. 50 times 0.1, so would you expect to have spent over 2 hours watching streaming services than online? So we want to see like the difference between how many people watch streaming services and how many people watch online videos. This is equal to 11.4, so 11/12 people This is like it kind of gets a bit messy with being calculated by hand, so yeah, it might not be the best. Yeah, so that's why I would definitely, and yeah, it's a lot easier with calculator. Give at least 2 reasons why a normal distribution may not be appropriate in these contexts of number of minutes spent watching streaming services and online videos. For all news and youth, you may want to include a sketch of what you expect the real distribution of one of these contexts would look like to support your answer. So, wait, let me pull out my notes. What did I write down? Okay, so basically, reason one. So basically, any valid reasoning is good as long as it is statistically accurate. So basically, reason one, what I wrote down is it's basically the the study measures only for positive values and normal distribution is considered with both positive and negative values. I spelled values incorrectly. Values. So reasoning 2. Yeah. So basically my second reasoning is it could not follow follow a normal distribution. The number of men's watched can be skewed and non-symmetrical. Hence, could not follow a normal distribution. This study also reported that overall New Zealand youth watched a daily average of only 34 minutes of TV. However, when excluding those who didn't watch TV at all, the average was 114 minutes daily. Explain the effects of including the youth who did not watch at all, the mean and distribution. Let me look at my notes again. So, okay. So, the mean is calculated by summing all values, then dividing by total number of values. If people not watching TV is included, then there will be lots of zero terms and hence low mean time. Then effect on distribution is it's basically it could be like, so basically it's just like lots of people could be like scattered here at 0 minutes, or like this. Lots of people could be scattered at 0 minutes here. Is 0 minutes. So lots of people could be scattered here. So it could be, so the data could be skewed. Yeah. Including the 0 values will heavily concentrate the number of people who watch TV at 0 minutes. Hence, cause the distribution to be skewed. Yep. So I guess just the mean is lower and it's extremely skewed. Extremely skewed. Assume a normal distribution. Model is the number of minutes New Zealand youth spend watching TV daily, with a mean of 114 minutes, excluding non-TV watchers. If 12% of New Zealand youth who do watch TV watching more than 150 minutes daily, calculate the number of standard deviation of daily minutes to watching TV. Here is 150, and the mean is 114. Here is 12%, so 0.12. So that just says this is 0.38, because that half is 0.5. So probability of 114 less than x less than 150 is equal to 0.38. So basically 0.38. Let's find 0.38 here. 0.3790. Then 3710. So the z value is 1.175. So z value 0.175 equals z. Z is equal to x take away mu over the standard deviation. Standard deviation is equal to x take away the mean over z, which gives x, we're given that it's 150 take away 114, 1.175, which is equal to take away 114, which is equal to 30.64 daily. Yeah, maybe I should say sigma is equal to 31 for significant figures. So thank you for I guess I do the usual guessing which values are guessing the marks. By the way, before when I exited out, it did not save, so that's why everything is blank now. At least I recorded everything, so that is great. So achieved merits, I think. And this will be E. I reckon this might be merit slash achieved. This is definitely excellence. That struggled me so much. Achieved. I reckon this there's a and I reckon this is an M. This is probably achieved. I reckon this is an E. I reckon this is another A. And this is an E. Although this is like quite a vague question. I did not really like that question. This is achieved, but I do this all on a calculator. I do not recommend you to calculate it by hand. This is merits. This is, I think, another merit. Yeah, will be excellence, I think. Merit excellence. Actually, no, I reckon like this is like a connected merit slash excellence question. I reckon it's connected. And I reckon this is merits. Yep, thank you for watching. Good luck for all your exams if you're watching it during the exams. Yep, I will record more tutorials and see you all later.